Yes, Harsh.
Yes, sir.
So see, Harsh, what we were studying is ether. Ether's uh, general formula we can write ROR. There will be
Yes, sir.
alkyl group beside oxygen
Yes, sir.
on both sides, left and right. So here ROR, that means ether is of two types, simple or symmetrical ether, or here mixed or unsymmetrical ether. Now, simple or symmetrical ether means alongside O, there will be equal, there will be same alkyl group, and alongside O, you can see both sides of O, there will be different alkyl group. So how we are going to name it? Alkoxyalkane. That
Yes,
means
sir.
the one which is in the
Parent
one,
chain.
no, not parent chain, the one with lesser number of carbon, basically
Yes, sir.
alkyl substituent, that is that we will use alkoxy, and the
Okay.
one with parent chain we are going to use
Alkane.
alkane.
Yes, sir.
Okay,
Yes, sir.
so this is how we are going to name it. So I'm going to give some nomenclature and you should practice it. Now see, I'm going to give you some question and then we will move to the preparation part. So the first question is CH3O, CH2, CH2, CH2. It is like this. Please try to solve it, then I will explain if you have any doubt.
Yes, sir.
Please do solve.
Sir, for the first one, is it
Yes,
methoxybutane?
methoxybutane, the first one, right?
Yes, sir.
No, not butane. See, this is the substituent and this is the parent chain. So its name will be methoxy. That is right. But you can
Yeah.
see how many number of carbon in
3.
parent chain? 3 carbons. So it will be propane now.
Propane, yeah. Butane. Butane is 4. Yes. Sorry, sir.
Please. No problem. Not a problem. Just be careful while naming.
Yes, sir.
Let me know when you are done with this.
Sir,
Yes,
for the second one, is it phenyloxymethane?
not phenyl. See, its a structure will be phenyl is the common name.
Oh,
Okay,
okay.
so it will be like this. Now you have to decide which one is substituent. That is this. This will be substituent. So
Okay.
its name will be
Methoxy
methoxy, and this is the parent chain. So it will be methoxybenzene.
benzene.
And its common name, which is very important, is anisole. What is its common name?
Anisole.
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 And
Okay.
question can be asked, write the structure of anisole. So in class 12th of organic chemistry, you have to be careful with some important common names of the compound. Okay.
Okay, sir. Okay, sir.
Very good. The third question is very important.
Yes, sir. So, sir,
Yes.
for the first one, the first part is methoxy. The rest part, we can't put di, right?
No. You have to number it.
We have to number it.
decide this
Yeah.
one will be
Okay.
the parent chain and this one will be
Yeah.
the substituent.
Yeah. So it will
So
be
how many
methoxy.
carbons? So no. You have to number it 1, 2, 3.
Yes.
And you can see on carbon 2, it's methoxy. So 2-methoxy propane.
Oh,
So you can see propane, that means 3 carbon. And
yes.
on second carbon, we have methoxy group, that means OCH3. Are you getting my point?
Okay, sir. Number this one.
Yeah. Very important question. Be careful with this.
Yes, sir.
And the next question is also very important.
So
Yes.
for the fourth one, there are 2 oxygen.
Yes, there is 2 oxygen. That means there will be 2 oxy. So
2
you can
oxy.
see This is also branch. This is also
Yes.
branch. This will be our
Yes, sir.
main parent chain. So
Yes, sir.
1, 2. So I'm going to write 1 comma 2. Dimethoxy.
Di. Okay.
2
Dimethyl.
methoxy is there. So
Methoxy.
dimethoxy ethane, because in parent chain we have 2 carbon.
Yeah. Two carbons. Yes, sir.
That's why dimethoxy ethane.
Ethane. Okay.
Got it?
Yes, sir. Just a minute, sir. Done, sir.
Very good. Now I'm going to again give you 2 or 3 nomenclatures name. You are going to name it. So the first is C6H5O, then CH2, then CH2, then CH, then CH3, and then CH. This one. And the second is there is cyclohexane, which there is CH3. This is CH3, and we have CH2, CH3. Again, I'm going to give you a very good question. C6H5O, CH2 whole 6. These are all questions from NCERT. Be careful while solving. You have to decide whether which one is parent chain and whether which one is
Yes, sir.
branch.
Yes, sir.
Let me know if you have any doubt regarding this.
Yes, sir. I'll solve and tell you.
Hmm. Are you done with the first one?
So just a minute, sir. Just a minute.
Okay.
Sir,
Yes.
for the first one, is it 2-methyloxybenzene?
2-methyl-oxybenzene.
Because benzene C6H5 and then
2-methyl-oxybenzene. See, I'm going to write the structure. You can see it will be like this: OCH2 and then CH and then CH3 and then CH3. Yes or no?
yes,
So
sir.
we have to take basically the substituent part and one parent chain,
Parent
right?
chain. Yes, sir.
So you can see these are lesser in number than the ring.
Yes. Yes, sir.
Only this have 4 carbon in regular manner and one
Yes,
is
sir.
substituent of this total 5. But here we have 6 carbon. That means this
Yeah.
will be parent
That's
and
parent
this
chain.
will be
Yes.
substituent. Yes or no?
Substituent. Yes, sir.
So we are going to number it 1, 2, 3, 4, so that the substituent of substituent will get lesser number, not from here. Wait a minute. Its numbering will be done 1, 2,
2,
3,
3,
4.
4. Yes.
Now its name will be 3-methyl, and then 4 carbon are there, so it will be butoxy.
Yes.
Butoxy. This
Okay.
is the
Yeah. Okay.
substituent for this.
Butoxy.
Butoxy and then benzene.
Oh, okay. So I did the numbering wrong.
Yeah.
I did something wrong.
Let me know when you are done with this. Am I visible?
Yes, sir.
So first of all, you have to see which one is branch and substituent and which one is parent chain. So
Yes,
you
sir.
can see here the parent chain will be cyclic. So I'm going
Yes.
to number it. This is also branch and this is also branch. This is also branch and this is also branch. So if you are going to number it, you can see since here are 2 branches, that's why I'm naming it, numbering it 1 and then 2. So its name will be 2-ethoxy according to alphabetical order, and then 1,1 dimethyl hexane, cyclohexane.
Cyclox.
Please write
Yes, sir.
it. Let me know when you are done with this.
Yes, sir. Yes, sir. Sir,
Yes.
is it 1-phenoloxy?
Phenoloxy, how can it be? Phenoloxy.
Not
Phenoxy.
yeah,
It will be phenoxy, not phenoloxy.
No,
Phenol is different.
Yes, sir. Yes.
Phenol is different, like phenol is this. This is phenol. And if you are going to use benzene as a substituent, that name will be phenoxy. So we can
Phenoxy.
see 7 carbons here and 6
Yes,
carbon
sir.
here. So its name will be 1 phenoxy and heptane. So easy.
Yes.
Okay. Can I change the slide?
Yes, sir. You can continue.
Okay. Let me know when you are done.
So done.
Very. Now we are going to see the structure of alcohols, phenols, and ethers. The name of the chapter is alcohols, then phenols, then ethers. So you know that this is alcohol, this is phenol, this is
ROR.
ether.
Ether.
Ether. Okay.
Yes, sir.
And phenol is also known as basically AR. We write AR. Aryl, that means arraign. Benzene, that means phenol.
Yes, sir.
Or it can ether can also be like AROR or AROR. OAR. Are you getting my point?
Yes, sir.
Now see, we are going to see the structure of functional groups. In this, we have 3 functional groups like alcohol, phenol, and ether. So I'm going to show you the structure of methanol. We know that methanol has a structure. Methanol has a formula CH3OH, right? CH3OH is methanol, and you also know that oxygen has
Methanol.
2 lone pair. This is methanol. So I'm going to write the structure of methanol, and basically this angle is 108.9 degree. The structure is not that much important, but you have to be careful when questions will be like distinguish between these functional groups. So also this is
Yes, sir.
142 picometer and this is 96 picometer. You know why this much difference? This much difference because of size. First, hydrogen is very smaller, and also oxygen is very electron negative than hydrogen. That's why oxygen attract its hydrogen attracts hydrogen electron, bonded electron towards itself, and there will be negative delta negative charge and delta positive charge. That will decrease the distance. That means the bond length decreases. In the same
Decreases.
way, we can go for phenol. So you know that this is phenol. This is phenol. And you also know
Yes,
that
sir.
again oxygen will have 2 lone pair. So I'm just going to write the bond angle 109 degree it is, and the bond length this is 136 picometer. Again, you can see if I'm going to write the name of this is phenol and this is methoxymethane. I'm going to write the structure of methoxymethane. So this is basically hydrogen, 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 again hydrogen, hydrogen, hydrogen. So this is basically 141 picometer. We don't need to remember the value, okay? But
Yes, sir.
this angle is 111.7 degree. Please write.
Sir.
Let me know when you are done with this. Do you remember Markovnikov and anti-Markovnikov?
Yes, sir.
Let me know when you are done with this. In this bit, we you didn't take any, you didn't give any test, right?
Yes, sir. Can you repeat?
You didn't give any test in this bit.
This week? No, sir.
No.
But yesterday I did the assignment they gave in the portal. So.
Hmm.
Done, sir.
Very good. So I will take a very little test today on
Okay.
nomenclature, basically. Don't
So
worry.
which chapter?
So this chapter,
This chapter. Okay.
yeah, alcohols and phenols. First of all, don't write alcohols and phenols. See, write the topic preparation of alcohols. How we are going to preparation of alcohol? So the first question is, from where you are going to prepare alcohol? So first is from alkenes. We are going to prepare alcohols from alkenes.
Alkenes.
Okay.
Yes,
And it's
sir.
very easy to understand, and the main important point is that you need to understand the mechanism also. Mechanism of the reaction. Okay, so here
Yes, sir.
you can see from alkenes, and in this there is a subtopic that is by acid catalyzed hydration. By acid catalyzed hydration, that means you are going to react alkene with acid catalyzed hydration. There will be basically you are going to add water in the presence of acid into alkene, then you will get alcohol. Are you getting my point?
Yes, sir.
Now see, it's very easy. Catalytic hydration, we also call it catalytic hydration. Catalytic hydration. Catalytic hydration. Now see, catalytic hydration, that means H3O positive. You are going to add H3O positive. If you have an alkene like this, CH2 double bond CH2, and you are going to add H2O, or you can call it H3O positive in the presence of acid. So what happens here? You are going to break this bond. This bond will be broken like this. It will move same electronegativity. So it will be like this. The bond, it's double bond, and it will be now single bond. And since on the right hand side the carbon which is present withdraw electrons of the left hand side carbon, so here it will be negative charge, and here it will be positive charge. Is that clear?
Yes, sir.
Now if you are going to add water in this, it will be two-step reaction. If you are going to add water in this, you know that water has two components, that is H plus and OH minus. So you know that negative part of the water goes to positive part, and positive part of the water goes to negative part. This negative part attack the positive part, and this positive part attack
Attack
the
the
negative
negative
part,
part.
and you will get your product that is alcohol. Are you getting my point?
Yes, sir.
Now, the important point is that whenever you are going to do any reaction, and if there is formation of carbocation, then rearrange if possible. Rearrange if possible. What does this mean? So rearrange if possible. If you are getting a carbocation, which is, you already know that in carbocation, first of all, you know that carbocation 3 degree, 2 degree, 1 degree. This is the order of stability, yes or no? If you still have any doubt
Yes,
in this,
sir.
please ask me. This is the order of
No,
stability
sir.
in
No, sir.
tertiary, secondary, and then
Yes.
primary. Very good.
Yes, sir.
So if you are going to react a reactant or a substrate, and you get a carbocation which is 2 degree, and beside that, adjacent to that, there is 3 degree carbocation, then that carbocation will shift to the 3 degree carbocation because it is more stable. Are you getting my point? If you have
Okay.
something like this,
Yes, sir.
if you have something like this is, and you are going to react with water, and now you can see this is 1 degree carbocation, yes or no?
Yes, sir. Yes, sir.
There will be hydride shift, and this carbocation will be shifted to this 2 degree. Okay, and
Yes,
the
sir. For stability.
product formed will be this, not this. So whenever there will be a situation or a state where carbocation formation take place, first of all, you are going to check if there is possible rearrangement. So you can do rearrangement. Okay.
Yes, sir.
Please write it, and then I'm
Yes,
going to explain the mechanism.
Yes, sir.
Let me know when
Yes.
you are done with this.
Yes, sir. Yes, sir.
Please write it here.
Done, sir.
Very good. So first of all, I'm going to make some question, not question, mechanism. See, the mechanism is very important. How does this work? Mechanism. So there are some steps which we are going to follow. Step one. First of all, step one, there will be protonation. Do you know what does this protonation means? Yes or no?
Protonation.
See, protonation. Whenever there is a
Changing of
no. What changing of? Yeah, you should speak. Changing of what? Whatever is in your mind. See,
I heard this
where
term, but I forgot. So I can explain it a bit.
see, wherever a term is like uh, alkylation, hydrogenation. The term in the
Yes.
end, ation. You can see
Okay.
ation, like hydrogenation, like chlorination. See, you are going to understand it and you will never forget it. Chlorination, ation, that means addition.
Addition
And
of
addition of what? Chlorine.
chlorine.
Halogenation. Halogenation. Sorry, hydrogenation. What is the addition?
Addition of hydrogen.
Hydrogen. If there is a term halogenation, so what we are going to add?
Addition of
Halogen.
halogens. Yes,
Halogen.
sir.
So if I am saying protonation, that means addition of proton.
Protons.
So in the first, and what is proton? If I am going to remove electron from hydrogen, if I am going to remove electron from hydrogen, it will be proton. This is
Yes, sir.
protonation,
Yes, sir.
because only proton is present here. There is no neutron also. Are you getting my point?
Yes, sir.
So in the first step, there will be protonation. Protonation of alkene to form carbocation. To form carbocation by electrophile. By electrophile attack of H3O positive. So see how good does how the reaction is going on. First of all, H2O acid catalyzed hydration, here it is. That means in H2O there is acid H plus, so it will attack and it will form H3O positive. Yes or no? Hydronium ion. This is
Yes,
called
sir.
hydronium ion. Okay.
Yes, sir.
Now we have an alkene. I'm going to take a general alkene like this. So in this you can see one point you have to remember regarding reaction in organic or in organic chemistry. In organic chemistry, more electronegative element, see, whenever there is charge on more electronegative, the charge positive, wait a minute, I'm going to write it. Negative charge on more electronegative or on most electronegative, more electronegative, so you can see if an element which is electronegative, highly electronegative, and if it has a negative charge, it is stable. Are you getting my point?
Yes, sir.
And if a more electronegative or high electronegative element is there, and on that element, if there is positive charge, then it is less stable.
Less stable.
Are you getting my point?
Yes,
In
sir.
the both way, you have to think. If there is positive charge on less electronegative element, that is stable.
Stable. Okay.
And if less electronegative element get negative charge, that is unstable. Okay, so you can see. Okay,
Sir,
I'm going to write. Yeah, I'm going to write.
Electronegative element, if it gets a positive charge, it should be unstable, right?
Yeah, I just said. See, again, you are. I'm going to write it. Negative
Yes,
charge on more electronegative element is a stable. Positive
stable.
charge on more
Unstable.
electronegative is unstable. Now think of think converse of this electronegative element,
okay.
Unstable. Now think converse of this. If there is less electronegative element, like hydrogen, are you getting my point? Like carbon, and if there is negative charge, then that is less
lagging,
stable. Am I lagging? Harsh?
Yes, sir. You were lagging on the previous statement, sir.
Okay. Wait a minute. Am I lagging now? You are mute.
Now it's fine, sir.
Okay, thank you. Now see, if negative charge.
Yes, sir.
This? Okay, are you there?
Yes, sir. Yes, sir.
Oh, wait a minute. See, if negative charge on more electronegative element, that is stable. Positive charge on more electronegative element,
Yes, sir.
unstable. If the element is
Is
if the
unstable.
element is less electronegative, then its converse will be true. That means negative charge on less electronegative element is unstable, and a positive charge on less electronegative element will be stable. Are you getting my point?
Stable. Yes, sir. Can
Got
you write
it?
that?
Yeah. I'm going to write it. Just positive charge on less electronegative element is unstable. You are going to write it. First write this, then
Unstable.
I'm going to write.
Yes, sir. I'll write this, sir.
You can think of converse of this: positive charge, positive charge, less electronegative element, stable. Are you done with this?
So just a minute, this is second point, sir. I'm writing on.
Okay. You can easily write the second point, second part of this yourself. Please think
Yes, sir.
about it and please write it yourself.
Yes, sir. Next. So the second part will be positive charge on less electronegative element is unstable,
No.
right?
Yeah. After this, na?
Yeah, after the second one,
This,
sir.
see, this is these both are for more electronegative element, and if you are going to write for less electronegative
Less.
element,
It will
and
be
if
inverse.
less electronegative on positive charge, then unstable. It will be converse, na?
Okay.
Less
Yes, sir.
electronegative
Unstable.
on less electronegative and negative charge, unstable, and less electronegative element
Unstable.
positive on positive charge, then stable.
Yes,
I'm again
sir.
repeating. There is positive charge on less electronegative element, unstable, stable. Positive charge, I'm going to write it. Positive
Yes, sir. You
charge,
can write, sir.
positive
Less
charge
electronegative.
on less electronegative.
Unstable.
No. Positive charge on less electronegative, stable. Positive charge, negative charge on less electronegative,
Unstable.
unstable. See,
Yes,
in
sir.
Hindi, what we call it, जो जितना ज्यादा नेगेटिव sorry, negative charge on more electronegative element is stable, positive
sir.
charge on less electronegative element is stable. Got it?
Yes, sir. Yes, sir. Yes, sir.
इलेक्ट्रोनेगेटिव चार्ज पे सॉरी एक एलिमेंट है जिस पे इलेक्ट्रो जो काफी इलेक्ट्रोनेगेटिव है उस पे नेगेटिव चार्ज स्टेबल होता है, और एक एलिमेंट जो लेस इलेक्ट्रोनेगेटिव है उस पे पॉजिटिव चार्ज स्टेबल होता है.
Yes, sir.
ओके,
Yes, sir.
यू अंडरस्टैंड हिंदी राइट?
Yes, sir. I understand. Done, sir. Done.
Let me know when to. Okay, I'm going to erase this. Now see, in the first point, I have written that there will be protonation of alkene to form carbocation by electrophilic attack of H3O positive. First of all, in H2O there will be acid that will attack water and form hydronium ion H3O positive. Now this hydronium ion will react with this. How does it react? It is very important. Now you can see oxygen is second most electronegative element. That means if there is positive charge on oxygen, which is unstable, yes or no? Because
Yes,
oxygen
sir.
is second most electronegative element. So
Yes, sir.
what will do oxygen? First of all, oxygen will remove this positive charge from itself. So what it will do? It will withdraw electron of hydrogen. It will withdraw electron of hydrogen. Now hydrogen will be H plus, yes or no? Hydrogen will be H plus. Now you can see oxygen withdraw hydrogen's electron and it will get one electron. So there is already positive and gains one electron. There will be negative. So it will be H2O. There will be no charge left.
Yes, sir.
Now you can see then this H plus is electrophile. Now there is no electron here. It is electron poor. It is electron poor or electrophile. So this will attack it. And what happens here is very important. So there is two bond and it will be now single bond, single bond, single bond, and hydrogen will be like this and like this. That means you can say this is double bond. So one bond, basically one bond will have two electrons. So this bond will break and one electron from this bond will go to hydrogen, and now you can see this will have one electron and this one will have positive and like this, and hydrogen will get one of its electron which will bond with this, then this carbocation will form. Yes or no?
Yes, sir.
So please write it stepwise. I am going to do it.
Yes, sir. Yes, sir.
Okay, take your time, no problem.
Done, sir.
Very good. Now in this second step there will be nucleophile attack. Since you can see this is carbocation, that means electron
Yes, sir.
poor species or electron deficient species. In step 2 you can see nucleophile or nucleophilic attack of water, nucleophilic attack of water on carbocation. There will be nucleophilic attack of water on carbocation. So you can see this is like this, and this has positive charge which has 2 bonds. So it is present in H2O, and H2O is electron rich species, that means nucleophile. So it will directly attack this. What happens here is very important. And see, this is a reversible reaction. See what happens. This will be like this, the left carbon. Now on the right carbon, you can see this is hydrogen, and oxygen give one electron to this, and it will make a bond with this OH2, and this there will be positive charge because oxygen just gave one electron to carbon, and carbon, since it is positive, will gain one electron. There will be negative charge, and already there is positive charge which will cancel each other. Okay. Now
Yes,
in
sir.
step 3 you can see step 3, deprotonation. Do you know what is deprotonation?
Removal of protons.
Removal of proton, very good. Deprotonation to form an alcohol. So we are going to deprotonate this product from the second step. That means you can see the second step is like this. It is like this. O plus H. You can see oxygen is less electronegative when there is positive charge. Yes or no?
Yes, sir.
So it will gain electron. It will withdraw electron from one of its hydrogen. Oh, wait a minute. I'm going to react this with H2 also. It will attract or withdraw electron from hydrogen, and what will form here, you can see. So when it will gain electron from hydrogen, there is already positive charge, and there will be negative charge because it gains electron from hydrogen. So it will be OH, and this hydrogen H plus will attack on water, and again it will form H3O positive. Now we got alcohol here. Yes or no?
Yes, sir.
Please write it.
Okay, sir. None, sir.
Thank you. Now you can see. Now the second preparation comes.
Yes, sir.
The second preparation is, wait a minute, I'm going to give you a question. Either it will be written like this or it will be like this. H2 in the presence of H. Please write the product. Name the product basically.
Name the product.
Write the product and write its IUPAC name also. That I mean.
Yes, sir.
Can you do this?
Sir, just on some time, sir. Sir,
Yes.
sir,
Yes.
sir, I solved it, but I don't know. I cannot name this.
See what happens here. First of all, you are going
Can
to
you solve and name it?
wait a minute.
Break the
I am
double
going
bond.
to show you. See, there will be two. There can be two
Yeah.
products H2O. You know that H plus and OH minus.
Yes, sir.
Now you can see that OH can be here
OH minus.
and hydrogen can be on the right hand
Yeah.
side. Again, wait a minute.
Yes,
I'm
sir.
going to show you. Because carbocation can be here and carbocation can also be here. Yes or no? Which one is more stable? The blue one or the red one?
Sir, the red one.
No, carbocation.
No, wait, the blue one.
2 degree, 1 degree.
Blue one, blue one.
But
Blue
in
one.
this, I told you that
3 degree.
if there is, I told you that if there is, I told you what I told you. If
So
there is a
rearrangement is
rearrangement
possible.
possible, here is the rearrangement
Yes,
because
sir.
it's 2 degree, and if you are going
Yes, sir.
to move this, rearrange this here, it will be more stable. So the product will be like this. Yes or no?
OH and yes, sir.
Are you getting my point?
Yes, sir. But the name of this.
The name of the product is 1, 2, 3, 4. You can see 2-methyl, and then 2-methyl butanol, butane 2-ol.
Oh, okay, 2-ol. Yeah.
This is the main product. Okay.
Yes, sir. Yes, sir.
Done.
So just a minute, sir. Done, sir.
Very good. Now see, I'm going to show you the second preparation that we call it hydro. Wait a minute. What its name? The second preparation is by hydroboration, oxidation, hydroboration, oxidation. In short, we also call it HBO. That means if you are going to do hydroboration oxidation of alkene, then you will get what you will get? Alcohol. Okay. Are you getting my point?
Yes, sir.
So HBO
Yes, sir.
stand for hydroboration. Also, in HBO we use B2H6, that is borane, and in the either B2H6 or THF. I'm going to name it what is THF. I'm going to write the full form of this THF, or H2O2 and OH minus. What is the name of THF? Do you know? Tetrahydrofuran. THF.
So tetrahydrofluoride.
Yeah, tetrahydrofuran. This is THF. So there will be always written on the arrow THF that you have to remember it. That means tetrahydrofuran. Then always remember that plus there will be, and here where whenever there will be HBO, there will be anti-mark.
Anti-Markovnikov.
And you remember what is anti-Markovnikov and Markovnikov?
Yes, sir.
What is anti-Markovnikov?
Sir, it will go to compound with more number of.
What will go to? That is important. What will go to?
The OH, right?
The negative part
Yeah,
will
the
go
negative
to
part,
that
the
carbon
negative part.
which has lesser number of hydrogen.
Yes, sir.
Sorry,
Greater number of hydrogen is
hydrogen in
anti-Markovitch.
anti-Markovnikov.
Less
Yeah,
is
yeah. So if we have RCH double bond CH2 and there will be HBO, there will be
HBO,
HBO, H plus OH minus HBO, that means this.
hydroboration
That means
oxidation.
this. Okay,
Yes, sir.
so there will be anti-Markovnikov, and you know that and anti-Markovnikov, this negative part will go to that carbon
With
which has greater number of hydrogen. So the product
negative.
will be this hydrogen.
Yes, sir.
Okay,
Okay, sir.
please write.
Yes, sir.
But in NCRT, if you will go through NCRT, there will be, it is in several steps that I am going to explain.
Sir, in when I studied NCRT for this chapter, I don't think this was there.
No, it is there by
Like this particular topic name.
Yeah, it is. It is.
It is there.
Yes, there it is. You will see it. Okay, today.
Yes, sir.
Let me know when you're done with this.
Yes, sir.
Okay.
Done, sir.
Done. Very good. In NCRT, you can see it is in several steps, and it basically give 3 moles of alcohol. And how does it give? See, if we have CH3, CH double bond CH2, and hydroboration, that means borane, basically BH3 whole twice, then we get borane B2H6. Yes or no?
Yes, sir.
So we are going to react this BH3. Can I write BH3 as HBH2 whole twice? Can I write this?
BH3 as HBU.
BH3 whole twice. Can I write BH3 as HBH2?
Yes, sir. You can. You can.
Now see, this bond will break and this bond will also break. Now what happens here is very important to know. CH3 and here hydrogen will come here. This when this bond will break, it will be H plus and this will be BH2 negative. So it will be CHH and this will be CH2 BH. Yes or no?
So, just answer, just answer.
Yes, just process it, and if you don't get it, let me know.
CH3 and then CH.
Anti-Markovnikov?
Yes, sir. Yes.
Yes or no?
With more number.
Yes.
Yes, sir. Got it.
Now again, you are going to react this with CH3, CH double bond CH2. Now see, be careful, please. Now this bond will break. Again, in BH2, what happens? It will be HBH. Now again, this bond will break. This is positive part and this is negative part. Okay.
Yes, sir.
So you can see this is already there. This is already there. So I am going to write CH3, CH2, CHH, CH2, and then CH2. And what happens here? The hydrogen will go to this carbon and BH will attach with this. That means there is BH only left, which will attach with CH2 and then CH and then H. Just process it. If you don't get it, let me know. See what happens here. I'm going to explain here.
CH2,
See, Harsh,
yes, sir.
I'm going to explain here. It is CH3, it is CHH, and there is CH2, and I'm going to write BH and H. Yes or no? And
Yes,
there is CH3, CH double bond CH2. Now what happens here is it is breaking, and this is also breaking. This is positive part, this is negative part. So positive will go to this, and negative will go to this. That means you can see I'm going to write this CH3, CH and H, CH2, and then CH2, and then BH attaching with this BH.
yes, sir.
And this BH will directly attach with this CH2,
CH2,
and then CH, this CH, and then
okay,
CH2.
and then CH3.
Now this hydrogen that we left will go to this
CH.
carbon, and it will be
Yes,
like this.
sir.
Yes or no?
Yes, sir.
So this happened
Okay.
with this.
Got it.
Please write it. And again, there will be the third step, because we don't need boron in the product. We need to make alcohol.
Yes, sir.
So please write it in, and in the third step, I'm going to explain how does it.
Done, sir.
Very good. Now see, I'm going to again react this reactant with the CH3. We have to do this reaction for thrice. Wait a minute. Can I write this? You can see this part and this part are same. So can
Yes,
I
sir.
write this? CH3, CH2, CH2, whole twice, BH. Can I write this?
Yes, sir. But then
Both are same now.
Oh, yeah,
BH is here.
yeah. Okay.
That means twice. That means if you are going to remove this, there will be like bond this.
Yes, sir.
Now see,
Got it.
this reactant will again react with this, and again you can see this bond will break.
Okay.
And I'm going to show you. This is hydrogen. So this bond will break. This positive, and this is
And then
negative,
negative.
and anti-Marconi. So it
Yes,
will
sir.
attack there. Now you can see CH3, CH2, CH2, whole twice, and B is going to connect with this CH2, and then CH, and this H plus will attack this. So it will also become CH2, and then CH2. So can I write this? this and this are same. So can I write
Yes,
this
sir.
CH3, CH2, CH2 whole thrice B. So this is the last
Yes,
step.
sir.
Please write it. There will be another step and we will get alcohol. There is last step and you will get the product. But always apply anti-Markovnikov as I applied in the previous method for the same question.
Yes, sir. Done, sir.
Very good.
Sir, just one minute. Net
Okay.
is lagging, sir. 1 minute.
Harsh, are you there?
Yes, sir. Yes, sir.
Now you are going to put this in H2O in the presence of H2O2
Okay.
and base OH minus. You will get a product. B will be removed and there will be byproduct BOH whole thrice and 3 moles of CH3,
CH3,
CH2,
2, and
CH2
then.
and OH.
Okay.
Please write it.
Yes, sir.
But you are going to do the anti-Markovnikov and you will get your answer. Mhm.
Done, sir.
Very good.
So there are 3 ways, right?
Yeah, yeah. I'm going to give you a question. Please write the product. Can you do this? Now see. After you see this, there will be anti-Marconi. Anti-Marconi curve, that means H plus and
Yes,
OH
sir.
minus.
You should apply
OH
that
minus will
word.
go to that carbon which has greater number of hydrogen, that means this, and hydrogen will go to
Yeah.
this. So it will be this, the product, butanol.
Yes,
Okay,
sir. I was solving it, sir.
very good. So I will see you in the next class. Please be prepared for the test next week.
Sir, it's this chapter, right? Alcohol,
Yeah, yeah,
phenols, and okay.
yeah. And there
Okay,
will
sir.
be some extra classes in the morning as we have talked about this.
Yes, sir.
So I will arrange some extra classes in the morning. You are free, right?
Sir, Friday and Saturday, sir. Sometimes I'm not free.
Okay, okay. Then I'll see you. I'll see it for tomorrow. Okay.
Yes, sir. You can say.